In this question, we'll find the roots of the polynomial equation, find the number and the types of roots. Here you have been given 2x squared minus 5x plus 14. This is a quadratic equation. Now we can easily solve this up in the calculator and select the correct option. Let us solve this. We have mod phi and it's option 3. Why? Because this is quadratic. Only option 3 gives you the solution for quadratics. Now here we have the coefficients of 2, minus 5 and 14. It's 14. Here we go. The answer is 5 by 4 square root 84i. But you can see there's no way none of this written in this form. And then it will be minus because imaginary numbers are always in conjugates. So let us write one of it and then the other one will be just minus I. I mean this entire term and I. But look at this. Here, which will be the correct answer? 87, square root 87 is there in 3 of these options. Now this can be eliminated because I is on the left side, this is wrong. But these, now there's no I over here, this can be eliminated. But how do we write this and this? It's the same thing, we can split out this 4, so it'll become 5 by 4 plus square root 87. Here we go, 87 by 4. And this I, instead of writing beside it, we can write it after it. And that is how it's written in the calculator. So we can match them up. So here is the option D. That is the correct answer. Now this one cannot be directly solved in calculator because it's option power 4. Some calculators can use this. Now it's not about solving it directly, finding the answers. It's about how many negative real zeros are there. Now the actual method, if this is say more than 4, say there's x to the power 5, you need to know the method. Now when it is positive and negative, I'll do for both. For positive real zeros, it's very easy. You should just see the number of times the sign changes. That means this is positive, right? It became negative, so 1. And then again from negative it became positive, it's 2. Now positive, positive, all are same. So done. There are 2 positive real roots, or it can be 2 positive real roots and then you can have imaginary roots as well. So subtract this by 2, it can be 0. So it's 2 or 0, that's what we tell. Imagine you got 5 sign changes in some other question. So it can be the 5, subtract this by 2, it can be 3 or 1. These are all the possibilities. But what about negative real zeros? Now we don't have positive real zeros, it's negative. So what we do is we put this x as minus x. Then everything remains the same. It's instead of x minus x to the power 4 minus 5, but now instead of x we put minus x to the power 3. Only this x value changes, see these. And now here it is plus 2x becomes minus x the whole squared plus 5 times minus x plus 7. Whenever there is even number in the powers, that's 2, 4, 6, 8, 10, the sign becomes positive. It becomes just plus 4. Because you can try this out. Minus 2 to the power any of this even powers, the final answer will be positive. But if it is say like 2, 4, 6, 8, but say it is odd numbers like 1, minus 1, 3, 5, 7, the negative sign remains. The answer will be minus something. So then what is the next term? Here the minus sign remains. So minus and minus will become plus. So it is 5x power 3. Why? Because there are 2 minuses now. Because it's odd power. Now this is even power. This will become positive. So it's plus times plus itself. It will be 2x squared. Now it's minus here. So minus 5x. And lastly we have plus 7. Now let's count whether the sign changes. It's positive, positive, negative. Now here there is one sign change, negative to positive. There is second sign change. So it's 2 maximum roots, negative real roots can real zeros can be 2 or it can be 0 because I told you to subtract 2, isn't it? So it's the option C here. That is the correct answer. Now let's look into more of the problems. Now they have told us to just solve these equations. Now the first one is just a linear function. The number of root can be only 1 because it's x power 1. How can you solve it? Directly in the calculator it is possible. That is 5x plus 12 equals 0. Or you can manually do it and then press shift and solve and then equal to, it's negative 2.4. So you can see here it's negative 12 by 5 is basically 12.4. You have one real root. Why? Because it's not I, it's not imaginary, it's real. All linear problems will have real roots itself. Let's solve this one. That is by mod 5 and 3. Here we have 1 minus 4 and then we have 40. Here you can see it's imaginary roots, I. Therefore, there are two imaginary roots, no real roots over here. Next, what do we have is x power 5, but we cannot solve this out. So what we do is we do, we can remove the common terms out. That is possible, or you can do some rearrangements of take one term out, and then you will have x power 4 plus 4x power 2, and then we can take u is equal to x power 2 and then solve it up, because this can be solved as quadratic. Now another thing is you can take highest degree. What is common degree? It is x power 3 that is common outside. What remains is x power 2 plus 4 that is equal to 0. See, now there is x power 3 here and then there is x power 2. Now we have to equate both to 0, isn't it? X cube is equal to 0 and then we have x squared plus 4 is equal to 0. So how many total zeros are there here? Now this is cube. So that is basically x is equal to 0, x is equal to 0, x is equal to 0. There are three roots here because it's the repeated thrice. We have power 3. What about this other one? You can use mod 5 and 3. And now let's type it out. 1, 4, it's 0 because there's no x term, and then we have 4. There are two imaginary. So there are three real and two imaginary. You can see here the solutions will be this one over here. There is three real, that is 0, 0, 0, and then there is two imaginary which we got plus or minus 2i. So this will be the answers. There are total 5 roots, 3 are real, 2 are imaginary because we got 2. When we solve the right side, we got I. That's plus or minus 2i. How can we solve this one up? Now this one, instead of x power 4, if we have x power 2 minus 625, yes, we can solve it as quadratic, right? Now we will do a substitution. Let's consider u to be x squared. So what is x power 4 then? U squared is equal to x power 4. So I'm just going to rearrange over here. Instead of x power 4, I'll write u squared minus 625 is equal to 0. Now can I solve this up? Yes, you can directly solve it by taking 625 to the other side, but I'll show you in calculator. All we do is mod 5 and 3 for quadratics. Now coefficient of u squared is 1. There is no u term, so it's 0. And lastly, we have minus 625 as the constant term. So the answer is 25 and minus 25. So u is equal to 25 and u is equal to minus 25. But actually u is not what we are solving for. We need x. And what is x? U is equal to x squared. So I will write it over here. X squared is equal to 25. X squared is equal to minus 25. And now I solve them up. You can use mod 5 3 itself. Now, but this is going to be square root 25. That's 5 plus or minus 5. And here there's minus. So x is equal to plus or minus 5i. How can you do that in calculator? See here, whenever you're taking square root of negative number, you will have to just do the number. 25 will be 5 plus or minus 5, but then remember to write I. Mod 5 and 3. Now remember here, when you're putting in the calculator, you must write x squared minus 25 is equal to 0. And here it will be x squared plus 25 is equal to 0. This is what we put in the calculator. We equate it to 0 and then solve it up. It's 1. Then there's no term, that's 0. And lastly, we have minus 25. So the value is 5 and minus 5. And what about the other one? It's just 25 here, positive 25. So it's 5i minus 5i. So the number of roots are 4. And you can see here, they are 5 minus 5. 5i minus 5i. That's 2 real and 2 imaginary. Similarly, we can solve all these. I'll directly start solving in the calculator now. It will be mod 5 and then we have option 3. It's 4 minus 4 and then minus 1. And here we go. The answer is just 2 solutions and they're real solutions. Let's look into the solutions. You can see it's plus, and then it is minus. So it's plus and minus and 2 real. Next one. Now here, okay, so it is not a direct problem because you can see it's x power 5 and then there is no other term, there is x. So what you can do in such cases is you have to remove the x term outside, and now it is x power 4 minus 81 is equal to 0. One root is x is equal to 0, but the other one is x power 4 minus 81 is equal to 0. You just remember in a couple of problems ago we did u equals x squared. So what is u squared? X power 4. So that is what we are going to do. But since it's the multiple choice part, I will show you a shortcut. Mod phi 3. First, now you need to know this much. It'll be u squared. So I'm going to use this. Let me write that part over here. U squared minus 81 is equal to 0. I'm directly going to use this out. That's 1, 0, and minus 81. What's the answer? It is 9 and minus 9. Now again I'll have to use mod phi 3 and it'll be 1, 0, but now write the solutions. 1 was 9, so you'll get plus or minus 3i, that is plus and minus. And then one more is minus 9, isn't it? So that will be positive or negative 3. So there are 5 roots. You can see here 0 is one of the root initially we got. Then plus and minus 3, plus and minus 3i. So therefore you can count out 3 real zeros, 0 minus 3 plus 3. And 2 imaginary, that is 3i and 3i, minus and plus 3i. Quadratics are pretty easy. Mod phi and 3. Type in the equation 2, the coefficient, sorry, 2, 1. And lastly we have minus 6. So the answer is 1.5, that's 3 by 2 and minus 2. So there are only 2 roots here. And there are 2 real roots. Both are real. What about this one? Mod phi and 3. It is 4, 0, and 1. It's two imaginary roots, minus and plus 2i, half of 2i. One is minus half I and plus half I. I told 2i, sorry. These are the roots. You can see in the calculator they're both imaginary. Mod phi, not 3 here, it's cubic. So mod phi and 4. Let's put in the cubic equation. It's only 1 before x cubed, that is a. There is no x square and x term, so it's 0 and 0. And lastly, we have 1. So it's minus 1. Then there is 2 imaginary. So there are 3 roots. 1 is real, 2 is imaginary. But because minus 1, then you can see 1 is half plus or minus root 3 by 2. You can write it like this or this form. It's up to you. And then minus. So 2 imaginary and 1 real. Here it is now mod phi. It's mod phi and 3. So it's 2 minus phi and 14. Let us see the answers. It's 2 imaginary roots over here, and these are the roots. You can easily solve them in the calculator. You can modify the form. If you split this 4, it's going to be what you got in the calculator. And here as well, mod phi and 3, minus 3, minus phi, and lastly we have 8. So it's 1 and minus 8 by 3. That's going to be 2 real roots. Both are real, negative and positive roots, but they are real numbers. There's no imaginary numbers, so they are called real roots. You can do the methods as well, but since you'll be given the choices, easy to do in the calculator. Again, it's mod phi, but this time it's mod phi 4. It's cubic here. 8. There's no x square term. 0. No x term. 0. And lastly, minus 27. So here we go. It's 3 by 2 and then 2 imaginary roots. So you can see that's the answer. It's 3 by 2 and then 2 imaginary roots. So it's 1 real and 2 imaginary. Now this one requires modification. We will assume u to be x squared. So u power 2 is equal to x power 4. So this will be solved as 16u squared minus 625. That is equal to 0. So now you do mod phi and 3. Let's put in 16. There is no x term, 0 and minus 625. So here we go. The answer is 6.25 and minus 6.25. So the value of u is equal to 6 plus or minus 6.25. Now if you're solving this u, that's it. But we need to find x value. So you need to substitute u as x squared. That will be again mod phi 3. Whatever you get these answers, put them over here. 1, 0, this doesn't change because the coefficient is 1 over here and there's no x term. Let's start with 6.25. It's going to be imaginary roots. It's 2.5i and minus 2.5i. And then what you do is change this to minus 6.25, and here we go, it'll be 2.5 plus or minus. That's it. So there are 4 roots, 2 imaginary, 2 real, and these are the roots. It's plus, minus, plus, and then I, 2 imaginary as well. What about this problem? It's cubic, mod phi and 4. It'll be 1, minus 6, and 7. The solutions are, okay, 3 roots. They're all real roots. 0, you can see here, 3 plus root 2, 3 minus root 2, and 0. This one, what you can do is, you can remove x term out. But see, now this is a little bit complicated. Let me show you. Why? Because over here, x power 5 is there. Now, if you're going to remove out x, this is going to be x power 4 minus 8x squared plus 16 equals 0. Now what? Now assume u to be x squared. So one root is done here. X is equal to 0. That is done. We have 4 more. But here instead of u, instead of x power 4, I'm gonna put u squared is equal to x power 4. Is that okay? So what I'm gonna do is, see, wherever x squared is there, I'm gonna put u, and wherever x power 4 is there, I'm gonna put u squared. So here this is gonna be u squared minus 8u plus 16, that is equal to 0. Now let me solve this up. Here we go. It'll be a quadratic form, mod phi 3. The coefficient is 1, minus 8, and lastly we have 16. So the values are 4. Okay, now it's only 4, but this is quadratic. So it's a repeated. Now this is having 2 roots of the same thing. It's repeated roots. So what happens is, the answer is over here, u minus 4 the whole square. This is the form we write it in. Okay, it's like this basically. But anyways, now we are going to solve it. There are u is equal to 4, u is equal to 4, because if it's a parabola, it touches, it should be at 4 over here, positive 4. So it touches over there, just over there. That means it is repeated twice. Now then, this needs to be solved again, right? Now this is pretty simple. X squared is equal to 4 twice. So mod phi 3, 1, 0, and 4. Just 4. Why? Because we have only positive 4. Sorry, it'll be minus 4. My bad. Why? Here it is plus 4. It goes inside. It'll become minus 4 equals 0. So it's 2 and minus 2. So here you can see what's happening. We got the answer. 0 was there already. We got x squared is equal to 2. So x squared minus 2 is equal to, sorry, it's 4, isn't it? Here it was 4. And then we got x is equal to 2, x is equal to minus 2. Yes, 3 roots, right? But what happened here? I told you, right, it's a repeated. So let me just go back here. The same answer is twice. So what I did over here, I need to repeat it twice. Basically, this is true. And again, I have one more root that's giving me the same answers because these are repeated roots. So therefore, I repeat minus 2, 0, 2, 2. And all are real roots here. I hope that's clear, because though it's a quadratic function here, we were just getting one answer. So that means it's power 2. That means the same thing is twice, repeated twice. So in such cases, you have got 0, it's fine. Now whatever the answer you get in the final, it was 2 and minus 2, just repeat it twice. That will be your final answer. That's how we do that. And here as well, it's the similar case. It's not the same problem, but it's a similar problem. Here x, we remove it outside, so you'll get x power 4 plus 2x squared plus 1. That is equal to 0. So now one root is done. X is 0, done. But what about x power 4 plus 2x squared plus 1 is equal to 0? You need to assume u is equal to x squared, so then u squared will be x power 4. Let's substitute in this equation here. It's going to be u squared plus 2u plus 1 is equal to 0. Now, after we write that, we can use the calculator to solve this, right? That will be mod phi and 3. The coefficient is 1, 2, and lastly we have plus 1. So the answer is minus 1. Now again it's repeated. I'm just going to write it once. So we got x squared is equal to minus 1, and bring it inside, it's going to be x squared plus 1 is equal to 0. But remember, this entire thing is repeated. I'll just write repeated twice. So whatever the answer I get it, I have to write it 2 times. Mod 5 and 3. Let me write this 1, 0, and then we have 1 again. So it's I and minus I, but there are 2 times I, minus I, minus I. So 4 times you have imaginary roots. So you can see it's minus I, and then 0. So only one real 0, that is 0, and then 4 imaginary roots. Now here they have given us this function, and over here what they ask is you can't just solve it up. Mod 5, 4, 3, minus 4, minus 17, and then lastly 6. You can see these are the roots, right? But what they actually want is how the zeros change, how many positive and negative real zeros are there. So in the solution, you can directly jump into the conclusion there are 2 positive real zeros, and how many negative real zeros? Only 1. So you can directly jump into that conclusion. But remember here, when you're solving it up, you should write like this. See, I'll tell you how it's positive real zeros. Just start counting. Plus to minus, 1 sign change. Minus minus, then again plus, second sign change. That is positive real zeros. It can be 2 positive or 0. So this is the possibility. So now you know it's 2, but you should do also 2 minus 2. So this is the solution. So this is why, imagine there was imaginary root, it will be hard to directly jump into conclusion. So just double check it in the equation. Now then, once you have got this 2 or 0, what next? Here then, you can change this x to minus x. Now what I'll do is over here, this is going to be minus x whole power 3, minus 4 times minus x the whole power 2, minus 17 times minus x plus 6. So this is going to be minus 3x cubed minus 4x squared. Why? Because this becomes positive and the minus remains. Now minus and minus will become plus 17x plus 6. What is the final answer? Now let's see the change in the root. Minus and minus doesn't, over here it changes 1. That's it. Only one negative 0 is possible. So it has to be 1 negative 0 and the remaining are 2. And we saw we got 2 positive real zeros, yes, and 1 negative. The table includes imaginary as well. See, now what is the possibility? You can have either 2 real zeros, 1 negative real zero, and this is cubic. So maximum is 3 roots. Done. There cannot be any imaginary. But what if you have 2 imaginary? Then negative real 0 cannot be negative numbers. It should be 1 itself. This will be 0. So then maximum 3. But the first case is the true one for this particular equation because we saw in the calculator. So here then we will try this. Mod 5 and 4. There is 4 minus 12 minus 1. And then we have 3. So what are the solutions? It's 3, half, and minus half. So we know there are 2 positive real zeros, 1 negative real zero. But we need to have the inclusion of imaginary numbers as well, isn't it? So you can write like this, 2 or 0. That is real positive real roots. Negative will be only 1 because there's only 1. Imaginary can be the 2 or 0. So this will be the final answer basically. See here, because there are 2 positive real zeros. If you use the Descartes, this is given by Descartes. I think so, the scientist name. Yeah, Descartes' rule. We pronounce it as Descartes. And that tells us how many positive or negative real zeros are there by the counting of signs. Now here, you can count the signs and get 2 or 0 for positive, 1 for negative, and 2 or 0 for imaginary. But imaginary cannot be found out here. You do the table. If there are 2 positive real zeros, then 1 negative real zero. How many imaginary? It's 0. But in case 2 minus 0, 2 minus 2 is 0, right? There can be 0 positive real zeros, 1 negative, and then 2 imaginary. So therefore, those are the situations. It's either 2 or 0 for positive, negative is 1, and then imaginary is 2 or 0. Similarly, you can solve this. We will do mode 5 and 4 here. It is 1 minus 8 plus 2, and then we have 4 minus 4, sorry. And here we have positive, and then you can see it's imaginary, and then imaginary over here as well. So one positive, two imaginary, no matter what. Since the imaginary numbers are involved, let's just count it out over here. How many? There's one sign change, two, three sign changes. So there is three positive real zeros or one. And then we know it's two imaginary. From this we can reduce, but it's better to use Descartes' rule and find the exact value. Here it's going to be minus x power 3. I'm not going to write it and change it directly. I'm doing it. Here the minus sign is also, it's minus 8x squared, and over here it'll remain minus x minus 4. Look at the sign changes. It's 0, right? So it's cubic. It's either 3, 1, 0. So, sorry, this is the thing. 1 or 2. Sorry, 0 or 2. It's 0 or 2. So what I'm trying to say is, you know there are three sign changes for positive real zeros. It can be either 3 or 1. And there were how many imaginary? We got 2 imaginary. So when there is 1, there can be 2 imaginary. And when there are 3 here, you can't have any imaginary. That will be 0. 2 minus 0, 2 is 0. So what is the negative zeros? Already it's full, cubic. All the 3 can be positive only. There's no way for negative. And over here as well, if 1, then this is 2. You can't have like 2 over here, because this is the, if you reduce it 2, you add over here, right? And if you do negative real zeros, it's basically 0 here. So this would be the solution. So it's 3 or 1, 0, 2 or 0. Again, let's now stick to this direct method, because this is more reliable. Because sometimes when imaginary comes, you can't only rely on the calculator, because you're getting solutions. We have to find the number of positive and negative and imaginary zeros, isn't it? So there is one sign change, there is two sign change, and then there is three sign change here. And what about the other way? It'll be minus x power 3 minus x squared minus 4 minus 6. There is 0 negative. Positive is 3 or 1. So imaginary I will be 2 or 0. So these are all the possibilities. Now let's look over here. That's the solution. It's 3 or 1, 0 or 2 or 0. Now we are power 4. We can't do this in calculator. We have to use Descartes' rule. It's no sign change, only one sign change. So positive real 0, it's only 1. That's the possible zeros. What about negative? So it's going to be x power 4. It'll be minus, it'll be again plus x power 2. See, here in the middle there is 0, okay? But we don't need to write it, because it'll be just plus itself. And then over here we have plus, there'll be minus and minus. So this is going to be only one sign change. So negative is also one possibility. Then what? Imaginary is 2 here. So here, this is the only possibility, because there is one positive, one negative, and then 2 have to be imaginary, because the total zeros possibility is 4, isn't it? So it has to be 1, 1. We got it from the sign changes by counting the sign change. So the imaginary is 2. There is no other possibility here. That's the only possibility. Now what about this one here? It's one sign change, then again another one sign change. Positive real 0 is 2 or 0. What about negative? So it'll be x power 4 itself, but this will change to x power 3 because sign changes. Now this will remain the same, and over here it'll be minus plus 1. So same, but there is one sign change, and then there is again second sign change. So negative can be 2 or 0. So what happens if there is 2 and 0? Then this will also be 2 or 0, imaginary. So these are all the possibilities. If you're writing it in the table, say for example, you have two positive real zeros, negative and imaginary, right? Two negative. How many imaginary is possible? 0. Then there is, imagine there is 0 positive and there is 2 negative, then there is 2 imaginary. There's one more possibility. Here there can be 2, And this can be 0, and then this. So these are all the possibilities here. Okay, then I missed one more. What is that? Both are 0. Okay. What if they both can be 0 as well, right? Then it'll be 4 imaginary roots. So these are all the possibilities. So it should be 2, 2, 0, 0 twice. So this is how we do it. These are all the possibilities. So you can write it out 2 or 0, 2 or 0, 4 or 2 or 0. Here, this is very important with the imaginary part because both can be 0, isn't it? Positive or negative. Then all the 4 will be imaginary roots itself. So this is a very important thing to remember. Here, then, it's only one sign, sorry, two, one over here and another one over here. So positive is 2 or 0. What about negative? It'll be the same. This is going to be 5. It changes its sign, odd power. Then this is going to be the same thing, changes, same. So it is 1 over here and 1 over here. So it's 2. Again, it's 2 or 0. And imaginary can be 4 or 2 or 0. Why? Because we can see the table. It can be 2 positive, 2 negative, then 0 imaginary. But it can be 2 positive and 0 negative, then it's 2 imaginary. In the first case, it was 0 imaginary, then it's 2. What if positive is 0 and negative is 2? Then 2 imaginary. But what if both positive and negative real zeros are 0? Then it will be 4 imaginary zeros. These are all the possibilities, but when we write, we just write 0 or 2, 0 or 2, and over here, it's either 0, 2, or 4. Back to cubic, you can use calculator to check the values. Here it's 1, and then there's no over here, it's 2. So positive is 2 or 0. What about negative? This is going to be minus 2x cubed minus 7x squared plus 2x plus 12. So it's only one sign change over here because then it's again positive itself. Only over here minus to plus changes. So it's 1. How many are the imaginary? So over here it can be only 2 imaginary. Let's look into the table. These are the conditions which we just write. There can be either 2 positive real 0, 1 negative, then imaginary are 0. But what if positive is 0? Because this or this, right? Negative is 1 itself. It doesn't change. Imaginary will be 2. That are the only conditions. And here now we have power 5. But it's the same thing. Minus to plus. One sign change. Again, last one sign change. Positive is 2 or 0. What about negative? It'll be 3x power 5 because the odd number sign changes here. This will remain same. And over here also it will be remaining same. And then minus 8. So same, same, same. There is only one. So negative is only one possibility. So imaginary basically can be. See now, if this is 2, then how we do is, let's do the table. There can be 2 positive, 1 negative, positive, negative, and imaginary. So what are the remaining? It is x power 5, 2 minus 2 and 1. That's 3. 5 minus 3 is 2 here. 2 will be imaginary. Now another thing is 0 and 1. So this is going to be 4 here. So that is the conditions. So you can see there's only 2 possibilities. But now how many possibility for imaginary? It is either 4, 2 or it has to be 4 and 2. You can't have 0 here. Because see, no matter what, there is one negative real 0. So these are the only 2 conditions. You can't have more than that condition. So here you can see it is either 0 or 2, 1 and 2, and that is 2 and 4. I hope that's clear. This is 2 or 4. That's the only possibility. Here you can see 2, 0, 1, 1. That's only once you can write, and 2 and 4. Here we have how many sign change? 1 and 2. So positive is 2 or 0. What about negative? It's going to be x power 4 minus 2x squared plus 5x plus 19. So there's 1 and 2. Again, it's 2 or 0. That is for negative. So we have 2, 2. Then it's going to be 0 imaginary. Or it can be 2 and 0. Then it's 2 imaginary. It can be 0 and 0. Then it's 4 imaginary. Or it can be 0 and 2. It can be 2 imaginary. So imaginary is either 0, 2 or 4. All the 3 possibilities are possible here. So here we go. These are the four cases which I just wrote down. And so here we have 0 or 2, 0 or 2, but this is 0, 2 or 4. Now it's power 6, but method is just the same. Here we have 4 plus, there's one sign change, second sign change. Positive will be 2, 0. Negative will be 4x power 6. Then we have, this is going to be the same thing because it's positive even power. That's going to be 5. We don't worry about the coefficients. We just worry about the signs. This is also the same thing, plus 24. It's literally the same thing. There are two sign changes only for negative as well. Now here, you can either have 2 or 0. Here, this can be 2, 0. Now again, it can be 2, 0, then which swap it. Okay, these are all the four possibilities. So 2 and 2, that will give us, four roots, but there are two remaining. So that is 2 here, no matter what. Now if both are 0 and 0, then 6 here. If one is 2, then one is 0, then you have 4, and over here also 4. So the imaginary roots, there's no 0, but 2, 4, and 6 are the imaginary possibilities. So here we go. It is 0, 2, 0, 2 for both positive and negative. So 2, 4, 6 is for the imaginary roots. And here we can see it's the power 5. One sign change, and over here another sign change. Positive is 2 or 0. What about negative? So this sign changes, x plus 5, and over here again sign changes, and this also sign changes. So here we have only 1 and then all its minus. So negative real zeros would be 1. So how about imaginary? Let's do the table. It's very simple. 2 and 0 is the possibilities of positive. For negative, it's only 1 and 1. So it's 5, isn't it? So you can either have 3 is done 2 or 4. So these are the possibilities. It's 0 or 2, 1 and 2 or 4. Whatever we do in the table, just write it out over here. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.